learn how to construct shear force diagrams according to bending moment diagrams and solve reactions according to shear force diagrams. Last time, we discussed how to construct a bending moment diagram according to superposition principle. Only under the action of two end couples MA and MB, we could construct a bending moment diagram. It's a diagonal line. The bending moment diagram is a fault line under the action of a concentrated load. Then we could obtain bending moment diagram for the original structure by using superposition method. We take this straight line as a baseline and superimpose such a fault line. The ordinate here is a quarter of PL. When construct the shear force diagram, we could also use superposition method. Construct the two cases shear force diagrams according to their bending moment diagram. Look at the first case. Its bending moment diagram is a diagonal line, so the shear force diagram is a straight line parallel to the axis. The slope of this bending moment diagram is equal to MB plus MA over L, negative. So this is the shear force diagram corresponding to the first case. For the second case, the shear force diagram is straight line for two parts. For the left part, the slope of the bending moment diagram is a quarter of PL over half of L, so that's positive half P. For the right part, the slope of the bending moment diagram is negative half P. So when we draw the shear force diagram for the original structure, we could draw this straight line shear force diagram as the baseline. Then superimpose such two parts, straight lines. This value here, the dashed line, is negative MA plus MB over L. Then we plus half P. So the final result for this part is equal to half P minus MA plus MB over L. And for this part, the value of shear force is equal to negative half P minus MA plus MB over L. By using superposition method, we could obtain this shear force diagram according to bending moment diagram. Actually, here, when draw the shear force diagram, for this dashed line of the bending moment diagram, we could draw its corresponding shear force diagram here as a dashed line. Then superimpose these parts and these parts separately based on this dashed line. We obtain two straight lines parallel to the axis. Now let's see how to solve support reactions according to the shear force diagram. Firstly, let's take support A as a free body. We could draw the free body diagram, the support reaction Fya, and the shear force of section A at right side is equal to positive half P minus MA plus MB over L. So the shear force is downward. The value is half P minus MA plus MB over L. According to sigma Fy is equal to 0, we could solve that Fya is equal to half P minus MA plus MB over L. When solve the reaction of support B, we could also take support B as a free body. The Fyb is what we want to solve. For the left side of section B, the shear force of the left side of section B is equal to negative half P plus MA plus MB over L. Because the shear force is negative, so that's downward. Then according to sigma Fy is equal to 0, we could solve that Fyb is equal to half P plus MA plus MB over L. Let's construct the shear force diagram of the overhanging beam and solve its reactions. Firstly, let's construct its bending moment diagram by using superposition method according to what we have learned last time. So, for this overhanging beam, it could be divided into three parts, AB, BC, and CD. For the AB part, it can be considered as a cantilever beam. Under the action of QL, obviously, upper side in tension. The M for the AB part is a diagonal line. Section B's M is equal to QL times L, so that's QL squared. For the CD part, it could also be considered as a cantilever beam. Under the action of uniformly distributed load, upper side in tension and the bending moment diagram should be a parabola. For section C, its M is equal to half of QL squared. So we connect section B, C, and D's M. These section B and C are control sections. If we determine the section C's M, we find that actually BCD part is a straight line. Then we take this dashed line as baseline. For AB part, no other external loads acting on it, so we just use such a straight line to substitute the dashed line. For the CD part, we could take this dashed line as a baseline, superimpose a parabola, because this part is under the action of uniformly distributed load. That's the same for the BC part. We take this dashed line as a baseline and superimpose such a parabola. The value here, the middle section of the BC part, is equal to QL squared over 8. This is the bending moment diagram for this overhanging beam. Then let's construct its shear force diagram according to the bending moment diagram. Firstly, we draw the dashed line for the shear force diagram according to the bending moment diagram's dashed line. For the AB part, the bending moment diagram is a straight line, so its shear force diagram must be a line parallel to the axis. The slope of the bending moment diagram is equal to QL squared over L, so that's QL, negative. For the BCD part, this dashed line's slope is equal to QL squared over 2L, so that's positive half of QL. Then we take this dashed line as a baseline. For the part BC, we superimpose a straight line. Because the bending moment diagram is a parabola, so its shear force diagram must be a diagonal line. We take this dashed line as a baseline, superimpose such a straight line. Pay attention here, this value is equal to half of QL and plus this positive half of QL. So finally, this value here is QL. And for this section, let's say, the baseline's value is positive half of QL, and the superimpose this value is equal to negative half of QL. So finally, this value here is equal to 0. For the CD part, we could also take this dashed line as a baseline, superimpose a diagonal line, because it's under the action of uniformly distributed load. The Q is a constant, so its shear force diagram must be a diagonal line. We could obtain the same value. For the right side of section C here, this value is half of QL plus half of QL, so that's QL. And for section D, the shear force is equal to positive half of QL minus half of QL, so that's 0. At last, we give sign for the shear force diagrams. Then, let's calculate the reactions according to shear force diagram. Take support B as a free body. For the left side of section B, the shear force is equal to negative QL, so that's downward QL. For the right side of section B, its shear force is equal to positive QL, so it's also downward QL. Then we could obtain that FYB is upward to QL. Take the support C as a free body. Let's say, for the left side of section C, its shear force is equal to 0, according to the shear force diagram. For the right side of section C, its shear force is positive QL, so that's downward QL. Then we obtain that FYC is upward QL. Today, we discussed how to construct a shear force diagram according to bending moment diagram, and then, according to shear force diagram, we could solve support reactions. At last, you should use the equilibrium condition to testify whether the support reactions are correct. That's all for today. Thank you for your attention.